Okay, folks, have a seat. We're about to start. Like I need to use this.
Ask questions to embarrass you. Please do.
The Pope will be here later. I hear he's very interested with OpenStack. That was a joke. Okay, so if you have a question, you make sure the mic arrives to you first, because we're recording and the quality will be much better if the mic is close to your mouth. So welcome everyone. I'm Haisam Ito, the co-organizer. Han Kim is another organizer, and he couldn't make it tonight. He went to see the Pope. No, I'm joking. Thank you, Mavenspire, for tonight's sponsorship, and Red Hat as a presenter. Also, thanks to you. And Mavenspire will tell us a little bit later what they're about and why they're interested in OpenStack and why they have the name Mavenspire. So today's topic is Bi-modal IT in OpenStack, and Mr. James Genus will tell us what that actually means. And the second presentation will also be by Mr. Genus, Red Hat Enterprise Linux OpenStack Platform 7. And we have till about 9:15, by the way. And we'll take breaks in between, so we'll relax. And these are the upcoming events by Mavenspire. The orange ones are the OpenStack DC ones. We'll have an October 15th. It will be in this venue, but in the theater downstairs, which is a really nice venue with a 90-person seat theater. And we'll have a November 19th one also. And these are essentially the same thing. Mavenspire sponsoring both. We're in the planning stage of what's going to be presented. And we are looking for additional presentations. If you have quick ones, short and sweet is fine. You're welcome to suggest a presentation. And don't forget the OpenStack Summit in Tokyo, October 27th. And this venue is the Goethe Institute. It's a nonprofit government cultural association that's worldwide, rather, and it's named after Johann Wolfgang von Goethe, which is a very famous German poet and polymath. And OpenStack Summit in DC, I think we should try to make it so. It hasn't been here yet, and there are rumors that they're trying for 2017 or 2018. Actually, the convention center is not far from here, so it would be ideal location. So I'm Haisam Ito, the organizer, and we started December 2011, so we're coming to our 4th year. I've been involved with OpenStack when it was called Nebula, under NASA Ames, because I work at NASA Goddard, which is affiliated with the entire NASA agency. So I'm going to pass the mic around. So introduce yourself, your name, and what brought you to this meetup tonight. And once we get to Scott, she will tell us about Mavenspire. So I'll pass the mic to you.
Laurent Delphos. I work at U.S. Courts over on the Hill. I actually signed up for the Red Hat Infrastructure Workshop they had last week at Microtech, I think, and couldn't make it. And they were covering the same subject, so I thought I'd stop in here.
My name is Tom Herbert. I work for Red Hat, but I'm a developer and upstream. Communities, mostly SDN-related technologies that are sort of a very kind of low level, but somewhat important part of OpenStack.
My name is Sarah, and I'm an account manager with Mavenspire.
My name is Rob, and I'm with Red Hat. I'm a cloud specialist.
The Red Hat takeover. Just kidding.
My name is Alex McMillan. I'm a network architect for Roka Security. I've been in the cloud space since 2008. Built and sold a data center in Ashburn.
My name is Stephanie Lamoureux. I'm an account executive with Yellow Fiber. And Alex brought me here tonight.
My name is Jeff Clark. I'm an engineer at Yellow Fiber. We have cloud services, and I've did a test deployment of OpenStack before.
My name is Manuel, and I'm just interested in OpenStack.
My name is Andy Lowe. I'm a software developer for the Sunlight Foundation, and I'm just here to learn more about OpenStack.
Hi all, I am Ari Wibowo from Embassy of Indonesia. I'm doing some virtualization there.
I'm Ty with 768 Alternative Solutions. We do OpenStacks and cybersecurity.
My name is Alexander, and I'm student. And okay, I'm student, and also I help Ty with cloud.
And please tweet and take pictures and upload the pictures to meetup.com. Thank you. Here's Scotty.
You're up. Hi, Scott Louisa Preston is my name, but everyone can call me Scotty, so I'm beaming you up. Feel well. I'm with Mavenspire. I'm in marketing. I am not here to pander. I'm just really, really excited about what is coming down the pipeline with this cloud, OpenStack systems. I mean, help me out. Virtualization. Yes. Software-defined networking. Thank you. And so Mavenspire, someone mentioned what is Mavenspire. So Maven means expert, and Spire is short for inspired. So we are inspired experts. And Michael Tannenhouse is our CEO, a visionary, and completely understands the importance of cloud technology, software-defined technology, which is one of the reasons that we are very strong partners with Red Hat, because Red Hat is setting the bar in many cases. But again, I'm not here to pander. On the other hand, we do have a technician, a solutions architect, who is going to present for you tonight, who is from Red Hat. So we can't just ignore where we're from, can we? That was the whole purpose of you guys telling us who you were. So having said that, we want to thank you very much. And if you have any other questions for us, please see us afterwards. And that includes Haysam, who is my new next best friend. And Haysam, I'll give this back to you.
Thank you, Scotty. And Mr. Genus, it's your turn. So there's a mic for you right there. We can, absolutely. Do you want to walk around with us? You need to use it so the video camera can pick it up. All right. So everyone, welcome
Mess up anything here. It is, yes.
And please remember to wait for the microphone, because the camera will pick the sound well. And I lost the mic. You can hold the mic. Here, why don't you take? Okay.
I'll take this one.
All right,
Does that work?
let's turn it on. It's green. Okay. There we go.
Okay. All right. I'll try to adjust accordingly. Thank you, Mavenspire, for having me here. I appreciate it. My name is James Genus. I'm a solution architect for Red Hat. I've been with Red Hat for, well, this is my 4th year. before joining Red Hat, I actually used to work for a independent marine laboratory off the coast of Maine. I was there for 10 years, and so a lot of what we were doing was looking at the Nebula project for early OpenStack deployments, data centers. If you're familiar with data centers and shipping containers, that's what we were planning to deploy. And so that's a great use case for OpenStack because you have the same commodity hardware, you can divvy them up for storage resources or for compute resources. And that's where I started a lot of the early OpenStack work. That would have been 2009, 2010, when that started to become public information. And we were on actually a NASA circuit, and that's the only way that I found out about it because we were doing work with NASA Goddard. So we're here to talk about bimodal IT. Are any of you, number one, please interrupt me at any time if you have questions. Throw something at me, whatever. I would like this to be a conversation, not just me up here, talking. So, does anyone here, have you heard about what bimodal IT is already? If you have, raise your hand. I know you two may have. Has anybody else heard about bimodal IT at all? At all? Only from the title. Only from the title, okay. That's a term, honestly, that came up probably about a year ago. And it's a term that Gartner created. And the reason they did it is, as we started talking about OpenStack, a lot of customers were saying, or being told, go to OpenStack, go to OpenStack, go to OpenStack, that's the future. Forget about what you've done in the past. That's just brownfield, you'll never have to do that work again. And customers would say, that really doesn't make a lot of sense, right? I've got my heavyweight workloads that live in virtualization. They're not going to go anywhere anytime soon. That's going to be there, but I need new architectures for new applications. I don't think that I haven't heard this discussed before, but I think the reason this has been happening is the ubiquitous of broadband. So in the year that I moved to Maine, which was 2001, I had the fastest broadband speed I could get at a house. At the time, I wasn't going to pay for T1, right? 56K, I'm like, I'm on the hot speed. I moved to Maine, and it was 28K on a good day if the wind was blowing right and didn't block the signal. In that time period, we didn't actually get broadband in my town until 2009. And it was my neighbor who told me she had a MiFi. And I said, it doesn't work. She said, it does. Come to the house, I looked at it, and all of a sudden, in this little device, she had T1 speeds. And I just sat there for a minute, and I was kind of astounded. I went back to the work, and I said, we now need to do broadband here. And so once you have all this pipe available, that changes the applications that you can push to your customers. That changes the way customers interact with your data sets as well. And that's what's driving the adoption of OpenStack more than anything else, in my opinion. So it is what customers are doing on the outside world. They come back to work and they say, you know what? On my phone, I can do all of this. Why can't you at IT internally do this as well? So there's a pressure then from the IT people to be able to match what you see going on in the outside world, and how do you merge those two? So traditional virtualization solves that in one case, right? We all went from physical to virtual environments. The next step is for applications that need to scale out horizontally. In my case, I had to deal with researchers who were supporting and analyzing data sets from cruises. We needed compute space and the ability to analyze that data over time. And virtualization just alone wasn't going to solve that. It had to be OpenStack, to be honest with you, because each researcher wanted their own environment, and I couldn't build out their own separate virtual environment to do that for them. It was either OpenStack or it was nothing. So that's the reason why, operationally, I could report back to the board and to the CEO. We're able to meet these needs for the business, and we can just add more resources over time, and we can do it in a supportable fashion. That's the driver for OpenStack. So at the end of the day, you need both of them. You need what you've done traditionally with virtualization, because that's not going to go anywhere. Email right now doesn't sit inside of OpenStack. Your ERPs don't sit right now inside of OpenStack. They may never sit inside of OpenStack. And that's the core business function as well. It's not going away. So for those things, keep it. You need that. For new workloads that need to scale out horizontally, build OpenStack for that. So what you'll see in most of this presentation this first one, is really on the business side. What is the driver for this? Where does OpenStack fit into the open hybrid landscape that Red Hat's talking about? This is not a new discussion for Red Hat. It has been one of the things that started roughly 5 years ago, maybe 6 years ago. We were very far out, much further than customers were ready to do at the time. It's now coming into fruition. So, for people who are not familiar with Red Hat, do you know how Red Hat works by any chance? We have these upstream communities. They are all, it's James. I have a community project. Enough people contribute to it that it becomes something that takes, market, and people want to do that. We at Red Hat throw some resources behind that in the form of engineers, right? There are people on our staff that contribute code to the upstream projects, which you'll see here in the middle column. And so for KVM, for instance, which is the community upstream for virtualization, we have developers who are committing code back to that project. The same thing for RDO, which is our upstream offering for Red Hat Enterprise Linux OpenStack platform, right? So we have developers writing code contributing back to the RDO project. The same thing, Fedora becomes RHEL. So that's the model that happens within Red Hat. Then on the right-hand side, you'll see all the supported offerings, supported products that ship from that. So for RDO, for instance, you get OpenStack. For Fedora, that becomes Red Hat Enterprise Linux. For CloudForms, the upstream community is ManageIQ. So even in the supported offerings, if we find an issue that needs to get fixed, that goes all the way back out to the community for everyone to get some benefit. We don't keep anything for ourselves. Red Hat shares everything. We collaborate. We make sure that everybody can be involved in that process, so that you know from start to finish exactly what's going on in a product. It's completely, you're in a group that looks at making sure that everything is open. That is exactly how Red Hat operates. You'll see, for instance, even for companies that we've acquired, a good example is ManageIQ. We acquired them in 2012. It's a private company with a proprietary software solution for managing infrastructure as a service, so things like VMware or things like that. We immediately began the process of making that an open source community, which became ManageIQ. So that gives you an idea of how Red Hat works. We do community, that's just who we are. We collaborate, we share, and you're welcome if you need to. If you see something that's lacking, let us know or write the code and put it up there, and you'll see it in the product if it actually is supported by the community at large. So, are there any questions around that? Does that make sense to everybody here? Okay. So again, we've talked about what's happening in IT. It is based on infrastructure. As we have bigger and bigger pipes going out, we can do more work. The question is, how do you make sure that as an internal IT organization, you can meet those needs that people will get by going to Amazon or by going to Google Compute or going to Rackspace? In a lot of cases, you cannot put certain kinds of data in public clouds. So you'll still need these functions, but you'll need to do it internally. So that's where something like Red Hat Open, our RHEL OSP offering comes into play. You deploy that internally, and then you can meet those functions and burst out to Amazon if you need to. But the goal behind all of this is to take your resources, reduce the operating costs, but give greater functionality to your organization. So part of that is because we're now seeing this applications being redone, and it's no longer just a vertical stack. It's being designed from the beginning to scale out, to assume that if hardware fails, it should pick up somewhere else and continue to run. That's a very different model than 5, even 6 years ago. This model did not, frankly, exist going back to 2001. So again, we talked about bimodal. Gartner, the term they actually use is mode 1 for virtual workloads or for physical workloads that haven't been virtualized, that run core business operations, your ERPs, your email, and things like that. But that model does not lend itself to flexibility, which is where OpenStack comes into play. So that's where mode 2, that's the reference that Gartner makes. It is in mode 2. And OpenStack, you'll see things around OpenShift in that space as well. So That's the real driver for Red Hat right now. And I don't want to make this a Red Hat only, but in principle, the idea is you have this open hybrid cloud. Today, your workloads might run in Amazon. Tomorrow, they might need to run inside your data center. You should have the same experience wherever those workloads exist. And that's really what our solutions provide, because it's the same platform RHEL underneath for all of that. So if you run it in Amazon, it's the same thing as running it in your local data center. It will function the same way. No changes are required on your part operationally to take advantage of that. What do you get from that? You get this great operational savings because you don't have to learn something new as you move from place to place. That's the first side of it. The second side of it is you get flexibility. You get the opportunity to move your workloads to the location that is most economical for your organization. Today it might be Amazon. You build a data center where your PUE is lower, pull it in there, right? And you save money by running it locally. All of that frees up your workloads to run where it's best for the organization. It's not defined then by somebody else. You decide what's best for you. So that, if there's anything you take away from all of this discussion tonight, that's what Red Hat is moving towards, doing what works best for you as a customer. We are completely a software company, so we have hardware certifications across the board. Wherever it can run RHEL, it can run OpenStack. It can run CloudForms, it can run OpenShift, which means that's Rackspace, Amazon, Google Compute, or your own data center on commodity hardware as well. So, any questions? Does this make sense to you? Is it valuable to you? I'm not just up here muttering along. So again, this goes back to Gartner again, there's not a whole lot of innovation happening on traditional Mode 1 environments because that's your core business, right? You don't see roads outside changing that much. What you see changing are the cars that go on top of the road. That's where the innovation is happening. So the applications will take shape once you put them into OpenShift or into OpenStack. At that point, you can design applications that you hadn't considered in the past because you may not have to worry about infrastructure as much. And you know that it can scale to meet your service requirements. What we haven't, I think what's coming up here is really where in the Red Hat stack do our offerings take place. And so on the far left side would be, we call it classic IT or Mode 1 again. That's RHEL, that's Rev. That's going to be our JBoss middleware offerings. On the cloud side, this is where again OpenStack comes into play. And Ceph for storage. So all of these over time, the goal is to make sure that as you move your workloads from either one of these environments, you have software-defined storage, you have software-defined networking, you have software-defined compute. So that means it's the same experience everywhere. There's really nothing new you have to learn as you move workloads from place to place. And I keep coming back to that because I had to actually report back to the board and to the CEO about how we were functioning operationally and how to do that planning every 3 to 5 years out, right? And operating in this sort of way meant we didn't have to worry about cost varying too much except going to external cloud providers at that time. So in Amazon, for instance. So I'm going to skip straight to this because at the real meat of this, and I think I've touched on this already, whether it's physical, virtual, on that side of the screen, the left-hand side of the screen, that's all Mode 1. Traditional virtualization, making applications work vertically as opposed to horizontally. Private cloud and public cloud, that's all Mode 2 work. That's where your OpenStack lives. That's where OpenShift lives. That's where XPass, all the middleware offerings that ship inside of, for JBoss that work in the cloud space, all of those fit in the far left. But you can move those workloads to run in all those places. So, wow, the contrast is tough to see here. But the slide on the left actually shows how many operating systems run in data centers right now. It's really down to 2, right? You have Windows, or even in enterprises, you have Windows and you have Linux, some version of Linux. I have lots of gray hair. I remember when Solaris was huge in this region, right? Everything. I mean, if you were going to do something, you had to be Solaris, certified, all that sort of stuff. That's gone. I mean, that's really gone. So, and part of the reason it left is that you were tied to both software and hardware. And at that time, there was a reason for that. Proprietary hardware performed better than commodity hardware. I'm going to be honest with you. If you go back to 1995 and 1996, DEC equipment was just awesome. You know, it ran forever. It just ran forever. Commodity stuff didn't run as well. So I wasn't going to put my trust in something that wasn't going to run for a long period of time because it meant, hey, it might not work. Right now, commodity hardware runs at very high rates. The mean time between failure, frankly, you ran data centers, right? You mentioned you built a data center out in Ashburn. Was it Ashburn? So what's your temperature? When you ran your data center, what'd you run it at? 68 to 72.
68 to 72.
Okay. So you'll see like some of the new data centers, they can run even up closer to 70, 80 degrees, and they don't need as much cooling because the hardware is better. And so operationally, that means your costs are lower, your commodity hardware runs fine, and what do you get? Great stuff at lower price. And you get the same hardware across the board. It functions either as a compute node, storage node, or in the OpenStack world, a networking node. That's all the three things you need. So all of a sudden, it makes your data center easier to design, easier to support, and your workloads in there can run, whether that's on-site or off-site.
So James, can you describe the y-axis and the x-axis of this left graphic?
Of the left,
it's hard to see.
It's really not very clear, and I apologize. So this goes back to, what year is this? 1996, right? And so Linux was, if you mentioned Linux in your data center, they walked you out. They just said goodbye. And I remember because my brother was the first person in our house to install Linux. And my dad came downstairs and he said, son, that looks like Unix. It finally looks like you have a real operating system. And my brother said it was Linux, and my dad started to pique his interest. He said, well, maybe it'll get there. Do you have a shell? You have all this good stuff. So in 1996, right, very few people actually deployed Linux in their environments and kept their jobs. They did it on the down low, and if it worked, then they started to see this increase. By the time early 2000s happened, you can actually see this move going from Linux is not really, it's not as bad as we thought it was, right? It actually works. And really what drove a lot of this is some certifications on the database side, right? And once that happens, it lends weight to using Linux in the environment. Oh, okay, thank you. Once you do that, let me see if I can use this correctly. It lends weight to using Linux in the data center. What also begins to happen here is, as adoption grows, Amazon comes out, right? Amazon makes its offerings available. Amazon's not using proprietary software. They're using Linux. They're using their own version of it, but it's still community-based code. And over time, Google, same thing. Facebook, same thing. Any of these large, innovative companies, they don't use proprietary software. They all use Linux to do that.
So are those server numbers, or are these?
These are, as a percentage, server in the data center, right? And there's also Windows, because we all know that on the client side, we're never going to win the war on the desktop as far as Linux. Let's be honest, right?
So server to server with Linux wins, but in the overall numbers, it's still Windows.
Well, it's Windows really on the desktop, to be honest with you. If you look at any data center, there are going to be some workloads that run with Windows, Active Directory, things like that. But those are the two operating systems that are left. You don't really see much Unix anymore. It's going to be some flavor of Linux. We hope it's going to be Red Hat, but Linux is still Linux. It's good for us, right? Yeah. Yes. And so, thank you, because that actually that is the alternative on the RHEL side. The other aspect here is in relationship to OpenStack. When I talked to people 4 years ago about what I thought needed to happen in the data centers, they all looked at me and they said, James, you are crazy. And I said, well, why don't you virtualize all these workloads? I'm purely on a selfish side. I was tired of being on call. Anything that I can do so that I can have a normal work day, a normal 8-hour work day. I can put the kids on the bus. I can go to work. I can leave work, meet them for dinner. That's my life, right? I love that. I'm not your typical IT person. I want to be able to do all of this stuff, not just a part of it. So how do you solve that problem? Well, you take hardware out of the picture as a failure. You make sure the services, if they fail, if the hardware fails, your services don't fail. So you virtualize all of that. And our plan was to virtualize our HPC cluster. Yes, you take a performance hit. It's not the same thing as bare metal. But would I rather take the performance hit and the service runs continuously so the researcher doesn't have to lose their work, or do I get the performance hit when the hardware fails, we have to redo all their workloads? I'll go with the first, you know. So I said to my peers, virtualize your environment. And you're like, oh man, you are crazy. Nobody does stuff like that. Performance is terrible. And I was like, but it's, you know, it's RHEL, it's Zen. That's when we went from Zen to KVM. I'm like, it's almost line speed. It's awesome. You're crazy, James. 4 years later, I get emails from them. You were right, you know. And I was like, well, thank you. I appreciate that, but, you know.
Where's the check?
I went off, I was like, I'm going to be depressed for a little bit because, you know, I didn't have to leave Maine and all that good stuff. But so what you see now in terms of what's going on is that, you know, OpenStack is here. And I know this is the meetup. I'm sure you all are very technical people, right? You all know the guts about OpenStack. What does it mean to the business, right? At the end of the day, this technology means that a business can lower their costs and get the same benefit and sort of hand off a lot of day-to-day operations to the groups who need to use these tools, as opposed to us in the IT field having to manage all of that. So, and the good part about that is, then we can sit back and make sure there's enough resources for the organization to work. That's the real value that we bring. We become enablers, not a bottleneck in the process. So, a lot of companies, I spent, well, I just moved back from Maine to Maryland last year. So most of my time was spent in New England dealing with large-scale deployments of OpenStack in healthcare industries, and finance industries, and publishing. So there's a lot of traction going on. And a lot of companies see the value of this. And they're really putting a lot of their, I would like to call it faith, but it's not really faith. Faith implies that you hope it's going to work. One of the things about Red Hat is the products that we provide actually do what they're advertised to do. So you're not really taking a risk by deploying them. That's the first issue. And so they really have supported what we're doing here and deployed OpenStack across their environment. And some of the large, I don't want to name customers, but they're large-scale customers using OpenStack up north. Maybe your healthcare is part of that engagement as well. So I have 2 remotes, so I'm sorry. So again, Red Hat, we're just a software company. And this might vex some people because they're used to buying hardware and software combined. We leave the hardware decisions up to you, right? Buy what's best for your organization. What saves you the most money, what solves your performance problems. Put RHEL on top of it, and it runs the best way that you know how. And so Red Hat Storage is that other aspect. In 2011, we acquired Gluster. So are people familiar with Gluster storage at all? File-based storage, single namespace available through multiple protocols, NFS, CIFS. And what does that mean? All of a sudden, you can deploy software-defined storage, have a single namespace, whether it's going to be an Amazon Rackspace, Google Compute, or your data center. The same namespace can be referenced, so your applications don't have to struggle as much. Not a lot of customization you have to do at that point. So simplification means more efficiency across your different environments as well. That's a huge one. That was 2011. And it validated that I wasn't crazy, because that's what I was looking at for our data center deployment at the time, for our scientists, using Gluster as the backend storage for all that workload. In 2015, 2012, we acquired Ceph. And if you know OpenStack, you know that Ceph is the sort of de facto backend storage for all of these deployments. We still have the Ceph community. It's just a supported offering now, where we actually have engineers on board doing that work going back into the community, making sure that these advancements are available to everybody, whether it's community or supported products. So, on top of that sits CloudForms. That's our Manage IQ application. We acquired them in 2000, I feel like it was 2013. The goal behind all of this is to give you a single, literally a single pane of glass across all of your deployment options, whether that's mode 1, which is your physical virtual environments, or mode 2, which is your cloud environments. So this tool sits above that, can look in through VMware, can look in through Amazon, through Rackspace, through Google Compute, actually allow you to see all those within a single application. What's the benefit of that? I mean, if you were in my shoes running data center operations for an organization, one tool allows you to see all of your environment. So I don't have to learn 50 different ways to do this. I use CloudForms. More importantly, I can actually do chargeback and compare the costs between running stuff in my data center versus Amazon or versus Google Compute. And I can feed that information back up to the board, to the CEO directly about what it costs us to run workloads across these different environments, which then affects the way that funding happens for the researchers, or in your line of business, the way funding is divvied out to them, because now it's based on real data, not what we think is happening, but what's been measured over time. So, yes, sir.
Wait, just 1 second. Let me bring.
Would that replace the two, Horizon and Heat?
Excellent question. So the question was, does CloudForms replace Horizon and Heat? At a high level, yes, it does, because you build in a service catalog through CloudForms. The service catalog may be for a line of business says I need an application that needs 5 servers. The 5 servers get deployed automatically into an OpenStack environment through a Heat template, right? So it ultimately means that your end users don't have to go look at OpenStack directly, and there's some value to that, because OpenStack, the functions are going to change over time, and you may not want your users tied to those specific functions. You want them using what you can support and what works best, right? The single point of entry for all of that. And that's the same thing whether that's going to be OpenStack, or whether it's going to be your VMware tool set, or even Amazon, or Rackspace, right? So you build up the service catalog on top of all of those things, then that means they don't have to know about the underneath unless they really want to. They can just say, I need this item, click on it, go, and it's approved automatically. And if it's not approved, then it goes up to the chain to management to approve it. So, but it gives you visibility from the operations side about the resources across your entire environment. So that's the other value of this. It's no longer what's happening in VMware, what's happening in Rev, what's happening in, in Amazon independently, and trying to correlate all that. What's happening across my whole IT environment. So, and the reason this is important, again, this is this idea of the open hybrid cloud. It is you work where you need to work best, and these tools support that.
Because in the CloudForms, if you manage overall, but you have a different service, different group, for example, manage and control that. So where's the workflow coming in from the CloudForms if you want to, let's say, your storage, for example, you don't manage your storage, somebody else manages the storage. So how does CloudForms going to have some sort of a workflow to indicate that from the operational groups, the storage say, hey, I need 2 terabyte, for example.
Okay. It's a great question. So the question was, how does CloudForms manage sort of the storage aspect of it, right? Since typically storage functions are separated out from compute functions and networking functions. CloudForms will give you the ability to set parameters when people make requests for certain sizes or certain amounts of storage. So at the back end, all of your other things like OpenStack will have storage presented out to them, and then you set up limits to how your customers can consume that. So it might be that they need 10 gigabits or 10 terabytes. You set those up, and then it consumes that in the environment. And that's how you control that. And then it reports back what's been used, who's used the most, what's been provisioned but not used completely, therefore it's been wasted. How can you size that? So all of that can happen within policies based in cloud forms. So, yes, sir. So the question was, what is the upstream project for cloud forms? It's Manage IQ. And so that community just started, I feel like it was in March of 2015. It takes us about 18 months to go from proprietary to community, because we actually have to go through this process of making sure that everything is vetted and available for the community to use. So Manage IQ is the upstream for that. So, yeah. So I didn't, the questions are, how does this all relate to OpenStack? At the end of the day, OpenStack is one of the tools that lets you go through and meet your business requirements, along with your virtualization platform, if that's VMware, or if that's Rev, or if that's Hyper-V. And then also if you're using external cloud providers like Amazon or Rackspace or Google Compute. I say all of those names because those are already built in to the tools right now. Those work, right? Those work right now today. So if you want to deploy these things and test them out, you can actually do that. What's important, and the reason why we touched on cloud management, for any of, we're all doing virtualization here at some level, right? Some people have VMware, some people have just straight KVM. Is anyone using Zen still? Good for you. Awesome, all right. I used Zen for a while. What was that? Yeah, well, it still works. It's great. It's still supported. There's nothing wrong with it. The reason why, on the virtualization side, why VMware is where it is because they put the management framework for virtualization in place before anybody else. And the way they did it, guaranteed they were the only people who could do it. Then lots of resources, institutional resources get built up around that. You train my staff on VMware, right? And I'm not going to get rid of that, and you shouldn't have to. That's why you see this talk about cloud forms and management coming into play. The recognition that all of these tools, you're shaking your head. Is there some, is that, you disagree or, okay. I go back to this in terms of management because it's the management platform that lets you interact with all these different technologies. OpenStack, OpenShift, all of these different tool sets can be managed through. VirtualBox. I think I'll have to check on that. That's may not be part of the supported offerings yet. Yeah. It does, but we have a supported list of hypervisors, and I'm not sure if that's actually on the list. I know for a fact right now that Hyper-V is there, Zen is there, KVM is there. I'll have to check for VirtualBox. I haven't seen many in the enterprise. So that's why you see the focus on the management platform there. And in the absence of the management platform, it becomes very difficult to see what's going on across your whole organization as related to IT. So you can't report back up to management about what's going on very effectively unless you see the whole picture. So that's the importance then of cloud forms in that capacity. So, all that together, plus middleware, and I think that's, anybody using JBoss in the environment, or is this purely operations folks here? So that's how I am too. I'm data center, right? I build the kitchen, someone else brings the food in, that's the JBoss folks, they're the chefs, not me. You do not want to eat what I cook. But the middleware side, and I will say this also, I think that's probably the most important part. In my mind, the middleware folks are leagues ahead of just the fact they can think these applications up and create them. It's amazing stuff. That middleware application runs the same across all these different environments. That means your risk is significantly reduced when you look at an open hybrid cloud versus using proprietary technologies. So I always keep that at the back of the mind is, and I say this, 15 years ago, you didn't have these options. It was proprietary for the most part. Now, all the innovation comes from open source, period. It's Linux, it's RHEL, it's KVM, it's OpenStack. That's where all the innovation is happening in the upstream communities. We simply provide supported bits for you. So if you have a problem, you can call us and get your problems fixed. So the next part, you all know about containers, right? Most people say Docker. That's a format. You know what containers are? Okay. So Dockers are just a format. It's a container format. But basically, what does this give you? Real application portability now. Because you're just doing the binaries and the libraries and anything else you need in this image, this container image, that can run again wherever RHEL runs. So, including inside of OpenStack, right? So all of these tools now are set up to allow you to do quicker development of an application and run that application wherever you need to run it. That's the open hybrid cloud at the end of the day. That's the value. So it's really do once, but run it really anywhere. I mean, that's what Java was back in the day, too. The same thing is now happening with RHEL. You do it once, it can run wherever you need to run it. So that's the takeaway. It makes your life easier wherever you need to go. We actually have a specific offering here, which is Atomic Host. It's simply designed just to run Docker image, or, well, Docker images now, but containers in general. That's all it's designed to do at the end of the day. So, open source, if you have something, yes, sir.
Atomic cost is same as bare metal.
Use the mic, please.
Is atomic cost same with bare metal or hypervisor?
Good question. The question is Atomic Host bare metal or a hypervisor? Atomic Host can run as a virtual machine. It doesn't have to be bare metal, but if you have bare metal, it can run as bare metal. It's simply a pared down version of RHEL designed to run containerized workloads. That's it. So just like Rev, it can either be virtual or it can be physical, either one. What you'll see, and my experience is that in a lot of ways, even in the virtual environments, you're getting wire speeds. I mean, what I will say is that the trade-off, if I really want that level of performance, I would probably buy physical hardware. The more you tune a system, the more fragile it can become also. So the question is, what level of fragility are you willing to tolerate in your environment? At the end of the day, I prefer to have a more stable environment than fragile. And the reason is, hardware is always being upgraded. We were talking about 40 gig speeds, right? Hardware is always going to be upgrading over time. Right now, RHEL 7 supports up to 40 gigabits per second. Even though not all, you can't buy a card yet, commodity at that speed. But when that happens, RHEL 7 is already set up to run that. So if I keep my workloads virtual and replace my hardware on the back end, over time it's going to increase the speed of the applications. It has to. There's no other way around that. So I always opt for stability because that fragility means I'm going to be on call. And I may not want to be on call. If you want to be on call, tune the heck out of it, you know. And just make sure you're ready to answer the phone at 3 o'clock in the morning if it fails. So Atomic Host can be virtual. It can be physical. It depends on the response time of the application based on the people who are creating the application. So if they tell you they need a certain SLA, it may have to be physical as opposed to virtual. So, but you can run it either way. We can talk about this, but all innovation, frankly, is happening in open source. I mean, the reality is we're all benefiting from it. If you have a smartphone, there may be one company that doesn't open source. They shall go unnamed. But the rest of it, frankly, all of us consume sources, and we're consuming all of it. When I go to Starbucks, I'm hopping on a Google Fiber, Google network, right? It's all open source, it's all community. That's where innovation happens. So, we've talked about containers. Well, if you're familiar with containers, there's a registry that sits out in the world where you can pull down images and use them. There are questions about vulnerabilities and security, right? And so Red Hat actually has an offering in place to guarantee that any of the images are certified, they're secure to reduce your risk of a problem when you go into production. So that's really what we do at the end of the day. Our goal is to make sure you have the least amount of risk possible. So, and the best way to innovate in a supported fashion. I think we've covered this already, right? You simplify your environment. As you simplify your environment, that gives you more time then to do innovation at the end of the day, because you don't have to worry about customization at the lower levels. So that's really where this comes in. And over time, for those of us who have been in Unix environments for a long time, what was the mantra about Unix early on, right? Can anyone tell me? You might. No? You do? Well, okay, all right. Good answer. Really was do one thing and do it well. Right? That's why you saw all those different processes that were started up in a Unix system. That process just handled its one, it stayed in its lane, that's all it did. We're seeing the same thing now with applications, right? The applications are now being broken down into microservices. They do their one part well, that's it. And if you need to change that, you only have to change that little bit, but not the whole application stack like we'd had in the past. That's really where things are going. And you see that already in stuff like Netflix or name your application, where changes are happening behind the scenes hundreds of times a day. You don't see, actually, whenever I see a problem, I call, and they go, Mr. Genus, yeah, we'll roll you back, and the problem's fixed. So, and I think part of that also is they want to see if people are paying attention. They might actually intentionally cause issues, and they want to see if customers really care about that. If they don't notice it, hey, let's keep doing our development, our integration points. So that's where I think things are heading. And again, this is happening because of the ubiquitous nature of connectivity. As those speeds increase, you will see more of this decentralization happen on the application side across the board. So that's Red Hat. Why do you do it? Optimized data center, single way to run your workloads across the environment. And we've got a trusted ecosystem already set up for you to take advantage of in your environment. So, Hisam asked me early on, what role did OpenStack play in this? As you can see, and instead of OpenStack, it's a small little icon down here in the bottom. It is the foundation. It is one of the foundational pieces of what we see in terms of the cloud moving forward. OpenStack, virtualization of some sort, Amazon, these are not going away. So these make up the foundation of what's going to be your cloud moving forward. On top of that fits containers. Beyond that is microservices. And really at the end of the day, you have OpenShift, which is your platform as a service, where you deploy that environment, your developers dive right in and start writing code. They don't care where it runs and how it runs. It's just the same way they've written code all the time. So that's it in a nutshell. I mean, are there any questions about that? That's bimodal IT. If there's a takeaway, know that your workloads right now that are traditional virtualization, I don't call it legacy because there's a negative term that people say with legacy. It's real virtualization that's not going anywhere, period. That's going to stay. And then there are the new workloads, which are going to be your cloud workloads. You have to support them both. I mean, if you know of anywhere in the natural world that switches from one state to the other state without some point of transition, let me know. Everything goes through, you still keep with what you've been doing, but you learn and you start to change over time. So we've been saying that for the last 5-6 years. Gartner has put a term around it for bimodal. So that's that part of that presentation.
So who came up with the term bimodal IT?
Gartner did.
Okay, Gartner.
Yeah. And really it was because, telling someone your legacy or your brownfield or what you're doing isn't necessary, it really is not good. Because really they're doing core business. I mean, if I'm running ERP inside of my environment, that's core business. If I cut that off, the business ends, right? These newer things are icing on the cake right now. And so until we get to the point where you can move your core workloads into something like OpenStack, you'll need that around, right? For the next 5 years or so, maybe 10. So.
Any questions before we take a break? Okay, thank you, Mr. Genus.
All right, thank you.